Hi everybody, so I'm Bertrand. You can call me Bertie if that's complicated. I started Godot only 2 years ago, and what I love to do with it is to push it to its limits. And here are a few examples of what I do with it. So on the top left, you can see that I'm doing real-time audio conversion to music scores. I'm also doing fluid simulations using compute shaders. I'm having fun making coin pusher games and generating terrain using shaders in less than a few microseconds. But what I do most is game jam games, and I love to put hundreds of characters in them. Like here it's in 2D, but I come to the topic of this talk. What if you want to do that in 3D with rigging? And I discovered this problem with this game jam game. So it's a bit subtle, but all those characters here, they all have rigging in their animation. Like there is deformation on the mesh. Like you can see a few tongues like bobbing around. And the problem is that at first, with only 50 characters, it was already starting to make my game lag. So I investigated why, and here is what I found. So I'm starting here with a basic character which doesn't have rigging. So it's just an animation player, a few meshes, and the meshes are just moved around, but there is no deformation on the meshes. It's purely just either scaling or rotation or translations. And if you have one character like this, the FPS is extremely good, like 1000 FPS. You can display hundreds of characters like that. Like here it's 700, and you have still 300 FPS, so it's very good. And notice the CPU time here is 3 milliseconds for 700 characters. But if you switch to a character like that has deformation on the mesh, and so it has also a skeleton, so rigging, in other words, you can see that the CPU time is already 7 milliseconds, so it's more than 2 times slower than 700 characters without rigging. And so, of course, if you display 700 characters like that with rigging, you get essentially 10 FPS, which is not acceptable. And you might be wondering, maybe it's due to the meshes because they are more complicated. It's not blocky like before. We have a lot more polygons. And here I wanted to show you that I created a button to toggle all the animations. And when I disable them, automatically I gain FPS and I get back to 90 FPS instead of 10. So the problem is really with the animations. And you might also wonder that maybe it's due to the compatibility mode of Godot, and actually you're right, because in Forward Plus it's mostly fixed. But like a lot of people here, I guess, I like the compatibility mode because I like web export. I also like mobile support. So let's see how we can solve that. And the solution is Vertex animation textures. So I want to show you how to do that in 5 easy steps because it seems complicated. And unfortunately, shaders are involved, so it's going to be 5 easy steps, not so simple, unfortunately. And the step 1 is that you have to take your mesh and you have to transform it, to bake it so that it contains already the first frame of your animation. So here I'm taking the walk animation of this character, and so I created this mesh. That is the first step of the animation. And then step 2 is to create a table which contains all the movements that the vertices of your mesh are going to do over time. So you can see that each row is a different frame, and it contains the data for the movement in XYZ coordinates for each vertex, and it's relative to the first frame. So that's why we had to take the mesh to modify the mesh so that it contains the first frame already. And that's why also the first row is only containing zeros. Then step 3 is that you have to convert that into an image. And why is that? It's because it's to pass it to a shader, and shaders are done to handle textures extremely efficiently. So essentially, we take the table that we had and we convert it into an image. So we use RGB, but RGB here will mean just X, Y, Z. So really, the R channel is going to encode the X movement, etc. And you can see that the image is split in two because we need to do that for the movement of the vertices, but we also need to do that for the movement of the normals, so that as the character gets animated in space, you will see that the light will bounce correctly. If you don't do that, you will see weird kind of shadows happening everywhere, but it's not really shadows. And then step 4 is that you take this shader and you tell it to do the hard part of the job, which is to actually move the vertices in space. And we'll get more into detail for that later. And then you have to repeat the same process for each different material that you have, unfortunately. So it's a bit complicated, but in the case of the character I showed, we have clothes, in a way, just 3 leaves. So it's a different material. It was green and it had different properties. We need to make this another mesh for it, another texture for it, and same for the eyes, which are essentially just images moving to represent the eyes. And it gives you this. So you end up with just 3 meshes, no animation player, and magically the character is moving thanks to the shader. And then if you try to render 700 characters like I shown earlier, you get excellent FPS, like more than 100 here. You can even go further. You can use actually multi-mesh instances. So that's what I'm doing here. So I have just 3 nodes in my scene. Well, 4 with the container node. And I created, as you can see, there is a slider where you can change the amount of characters. And here I go up to roughly 3,000, and it's still pretty efficient. And you might be wondering, how do we do all that in practice? And first of all, we don't have time for details. It's a lightning knock. In short, you install OpenV8 in Blender. So yes, you will have to open Blender. You join your meshes so that you end up with 1 mesh for each material. So 1 mesh for the whole body. So if the head was separated, it needs to be with the rest of the body. And then you do what I will show you. So you go in Blender. You will have a tab for OpenV8 here. You select your mesh. And then you click on the button here called Encode Vertex Animation Texture. And it will generate the 2 files that I talked about. So the mesh that's baked to start the animation, and also the Vertex Animation Texture, so the image. And then after that, you copy this shader that I fully rewrote. So it's a shader, the official shader for Godot with OpenV8, which is a Blender extension. And I rewrote it because it was broken in many ways, like the normals, for example, didn't work at all. And also one last step is that if you see something very weird like that, it means that you probably didn't disable the compression on the vertex texture. So don't forget to do that, because you might think that everything is wrong, but it's really an easy fix. And as you can see, it's really pixel perfect after that. So really important. Also, don't export to like a compressed texture in the first place. It must be lossless. And so the pros and cons of it, the pros is that you get the best performance, and it's perfect if you want to show swarms of enemies that have like 1 or 2 animations. That's what I did in my case. But there are lots of cons. So yeah, it's more complex. You have to put extra work for each material, for each animation too. And it's not suited for all the skeleton users. Like if you have your player that will move bones dynamically based on player input, you can't use this technique, of course. And it doesn't support face normals. So it means that if you have a low poly style with shiny faces everywhere, it will smooth everything out, so it's not what you want. And breaking news, we have someone who actually worked on it in the last few weeks. Based on my work on this, he created this Godot plugin that allows you to more easily integrate lots of different animations for different characters. So it's better for instancing multiple characters. And thanks for listening. And if you have performance issues with your game, feel free to to contact me. All the links are in the QR code. Thank you.